Hello, and welcome to the Snoozy Scientist, where we drift through life's biggest questions one sleepy yawn at a time. Tonight, we're drifting into one of the oldest questions we've ever asked. Are we really alone in the universe? Is Earth the only place where life exists? Or could there be other worlds, far away, where something or someone is looking back at us right now? For as long as we've looked up at the stars, we've wondered who might be out there. In this gentle journey, we'll wander through what science knows so far and the clues that hint we might not be alone after all. We'll visit distant planets, listen for strange signals, and peek into the secrets hidden in ancient rocks and icy moons. Before we begin, I'd love to know, where in the world are you listening from tonight? Drop a comment and tell me what time it is where you're winding down. And if these gentle stories help you drift off, please tap like and consider subscribing. It keeps this little snoozy corner alive and cozy, and it means so much to have you here. Now, fluff your pillow, close your eyes if you'd like, and let's drift out into the stars together. When scientists look out into deep space, they see a universe so wide and full that it stretches the limits of what we can picture in our minds. Over the last 100 years, our telescopes and satellites have shown us just how much is out there. The numbers are almost too big to believe, but they remind us that Earth is only one small part of something far bigger than any one person or place. Right now, we know that the universe holds at least 2 trillion galaxies. Each of these galaxies is its own giant island of stars, gas, dust, and dark matter, floating through the empty dark. Some galaxies are tiny and faint, others are bright and massive, holding hundreds of billions of stars inside their glowing spirals. Our own galaxy, the Milky Way, is just one of these 2 trillion. It is home to an estimated 100 to 400 billion stars. That means that our sun, which feels huge and life-giving to us, is really just one ordinary star in a crowd so vast that you could never count them all in a lifetime. For centuries, humans did not know this. Long ago, people thought the stars were tiny holes in the sky or fires lit by gods. We did not know that each point of light could be its own sun, with its own family of planets. Now, thanks to powerful telescopes like Hubble and countless sky surveys, we know that stars with planets are not the exception, they are the rule. Almost every star you see when you look up at night has at least one planet circling around it. Many stars have more than one. Some have whole systems of planets, some small and rocky like Earth, some huge and stormy like Jupiter. When you add it all up, the universe likely holds more planets than there are grains of sand on every beach on Earth. That is not poetry, it is math. Astronomers have used real numbers to show that for every single grain of sand, there could be thousands of planets drifting around stars in distant galaxies. The Kepler Space Telescope helped us discover thousands of these faraway worlds. It searched for small changes in starlight as planets passed in front of their suns, blocking a tiny bit of light for a moment. From this simple method, scientists learned that Earth-like planets, the ones in the so-called Goldilocks Zone, not too hot and not too cold, are surprisingly common. Some scientists now estimate that there could be tens of billions of Earth-sized planets in the Milky Way alone. That means that in just our galaxy, there may be tens of billions of chances for life to form. This is where the math becomes even more amazing. The Drake equation is one way scientists try to think about the odds of other life. This simple formula takes what we know, how many stars there are, how many might have planets, how many of those planets might be habitable, and tries to guess how many civilizations could be out there trying to communicate. Every number we add makes the final answer bigger. It does not give us proof, but it shows that the idea of other life is not just science fiction. It is a real possibility based on what we see in the sky. Of course, not every planet will have life. Some worlds are frozen, dry, or blasted by radiation. Some might have oceans under thick ice, or storms too wild for life as we know it. But nature loves variety. Life on Earth has shown us that living things can survive in boiling deep-sea vents, frozen glaciers, and acid pools. If life found a way here, maybe it can find a way somewhere else too. This big cosmic perspective changes how we think about our place in the universe. It reminds us that Earth is special because it holds life, but it may not be unique. The building blocks of life, like water and carbon, are scattered through space. We find them on comets, in meteorites, and in the dusty clouds between stars. These are the seeds that could take root wherever the conditions are just right. Sometimes when we think about the search for other life, it feels lonely to know we have not found proof yet. The universe is vast and silent. Signals take years to travel across the emptiness, but the sheer scale of space also gives us hope. There are so many worlds left to discover, so many places that might surprise us. Next time you hear someone ask, "Are we really alone?" remember this simple truth. The numbers say life is possible, maybe even likely, somewhere out there among the stars. We just have to keep looking, listening, and wondering. And now, as you settle in for sleep, let your mind drift outward for a moment. Picture those endless galaxies, each a swirl of stars, each star with its own tiny system of worlds. Imagine that somewhere in that great sea of darkness, another mind might be looking up too, asking the same quiet question, who else is out there? And maybe someday, our signals will meet in the middle of all that space, reminding us that the universe is never as empty as it seems. The Goldilocks Zone. When scientists search the sky for places where life might exist, they often focus on something called the Goldilocks Zone. The idea is simple but powerful. Some places in the universe are too hot, some are too cold, but some might be just right. The Goldilocks Zone is a region around a star where the temperature is not too extreme. It is warm enough to keep water from freezing all the time, but not so hot that it all boils away. The name comes from the old story of Goldilocks and the Three Bears. In the tale, Goldilocks tries 3 bowls of porridge. One is too hot, one is too cold, and one is just right. When scientists talk about planets, they are looking for worlds that are not too close to their star and not too far away. A planet that sits in this special zone has the best chance to hold liquid water on its surface. And as far as we know, water is one of the key ingredients for life. Earth is the best example we have. Our planet orbits the sun at just the right distance. If Earth were much closer, like Mercury, our oceans would have boiled away long ago. If Earth were much farther out, like Mars, most of our water would be locked up as ice. But our place in the solar system keeps our water in a gentle balance. We have rivers that flow, lakes that shimmer, and oceans that cover most of our surface. Without this balance, life as we know it could not exist. For many years, Earth was the only world we knew that sat in the Goldilocks Zone. We dreamed about neighbors like Mars and Venus, but both planets turned out to be harsh and unforgiving. Venus is so hot that lead would melt on its surface. Its thick clouds trap heat like an oven. Mars is so cold and dry that most of its water is frozen beneath dusty red soil. But even these planets teach us something. They show how delicate the balance is. A little too close or a little too far can make all the difference. When astronomers began to look beyond our solar system, they wondered if other Goldilocks zones existed. In the 1990s, they started to discover exoplanets, planets that orbit stars far away. At first, they found giant gas planets, many times bigger than Jupiter. These huge worlds were easier to detect because their size made them tug on their stars or block more starlight when they passed in front. But soon, scientists developed better tools. They started finding smaller, rocky planets that looked more like Earth. One of the biggest discoveries came from the Kepler Space Telescope. Kepler watched a patch of sky for years, looking for tiny dips in starlight as planets crossed in front of their stars. From these simple shadows, Kepler revealed thousands of new worlds. Many of these planets sit right inside their stars' Goldilocks zones. Some are about the same size as Earth. Some are even closer to our size than Mars or Venus. Think about what that means. Instead of one small blue dot in all the dark, there could be thousands or even millions of planets where life might find a way. Each of these planets has its own story. Some circle stars cooler and smaller than our sun. Some orbit red dwarfs, stars that burn for billions of years longer than our sun will. These small stars can have Goldilocks zones that are closer in, like hugging a warm campfire on a cold night. Other planets orbit stars hotter and brighter than the sun. Their habitable zones are farther out, but the same balance applies. Scientists use the word habitable carefully. Just because a planet sits in the Goldilocks zone does not mean life is there. Many things have to come together for life to grow and survive. A planet might be in the perfect spot, but have no atmosphere to keep it warm. It might face fierce solar winds or be battered by constant asteroid impacts. But finding planets in these just right zones gives us hope. It gives us places to point our telescopes, places to aim our future missions, and places to dream about. Some of the most exciting future missions will look at these exoplanets in more detail. New telescopes like the James Webb Space Telescope can study the light that passes through distant atmospheres. If they find hints of water vapor, oxygen, or other chemicals that life produces, it could be one of the biggest discoveries in human history. It would mean that somewhere far away, under an alien sun, life may be busy shaping a world we can barely see. The Goldilocks Zone teaches us that life needs balance. It reminds us how precious our own world is. Earth sits in just the right place, wrapped in a thin blanket of air, warmed by a gentle sun, and protected by a magnetic field that shields us from harsh solar radiation. This balance allows plants to grow, oceans to flow, and people like us to look up at the stars and wonder who might be looking back. So tonight, as you drift off to sleep, picture those distant planets, each one spinning silently in its own perfect orbit. Imagine gentle rain falling on alien soil, or waves crashing on a distant shore under a sky with two suns. Somewhere out there, another world might be just right, waiting for life to wake up and wonder too. The Kepler mission's surprising data. Sometimes the biggest changes in what we know about the universe start with one small telescope pointed at a patch of sky. That is exactly what happened when NASA launched the Kepler Space Telescope in 2009. At the time, scientists knew that planets around other stars, what we now call exoplanets, were probably out there, but they did not know how common they were. No one could say for sure whether our solar system was normal or rare. The Kepler mission was designed to help answer that question. It did not look at the whole sky at once. Instead, it stared at a single patch of space, about as wide as the area your hand would cover if you held it up at arm's length. In that tiny patch, Kepler watched over 150,000 stars, looking for tiny, regular dips in their brightness. These dips could mean that a planet was passing in front of its star, blocking a small bit of its light for a short time. This simple method is called the transit method, and it turned out to be one of the most powerful tools we have for finding planets far away. At first, people wondered if Kepler would find anything at all. Would planets be common enough to show up in that small slice of space? The answers surprised almost everyone. Kepler found planet after planet, more than scientists ever expected. By the time its primary mission ended in 2018, Kepler had discovered more than 2,600 confirmed exoplanets. Many of these were small and rocky, like Earth. Some circled their stars inside the Goldilocks Zone, the region where temperatures might be just right for liquid water to exist. Others were gas giants bigger than Jupiter, or strange worlds called super-Earths that have no match in our own solar system. What Kepler showed us was clear. Planets are common, not rare. They are everywhere. If you look up at the night sky and see a star, chances are good that star has at least one planet, and probably more. This simple fact changed how we think about our place in the universe. For the first time, scientists had solid data to show that our solar system is not special in having many planets. It is normal. Kepler's data also helped scientists make a new estimate that still amazes people today. Based on the number of planets it found in its small patch of sky, astronomers believe there could be tens of billions of Earth-sized planets just in our galaxy alone. These are worlds that could be rocky, about the same size as Earth, and might even sit in their stars' habitable zones. That means tens of billions of places where life might find a way to exist. Think about that for a moment. Our galaxy, the Milky Way, holds about 100 to 400 billion stars. If even a small fraction of those stars have planets like ours, the number of possible Earth-like worlds is huge, and that is just one galaxy. As we learned before, the universe holds trillions of galaxies, each with billions or trillions of stars. The numbers get so big that they are hard to picture, but they all point to the same idea. The building blocks for life might be scattered far and wide. Kepler also showed us the wonderful variety of worlds that can exist. It found planets with tight, quick orbits that whip around their stars in just a few days. It found planets in double star systems, where two suns rise and set. Some planets are so close to their stars that one side is always facing the sun, scorched and bright, while the other side is frozen in darkness. Others may be covered in thick clouds, giant oceans, or landscapes we can only guess at. Scientists have spent years studying Kepler's discoveries, using computers to model which planets might have stable climates, atmospheres, or even water. Some planets might have conditions that are too harsh for life as we know it, but others, like the famous Kepler 22b or Kepler 452b, sit in that just right zone that makes people dream. If there is even a tiny chance that life exists on some of these worlds, it is enough to keep astronomers searching. Kepler's success inspired new missions too. The Transiting Exoplanet Survey Satellite, or TESS, was launched to continue the search. TESS scans the entire sky for exoplanets, building on what Kepler started. Powerful new telescopes like the James Webb Space Telescope will help us look at these distant worlds in more detail. By studying the light that passes through their atmospheres, scientists hope to find clues like water vapor, oxygen, or other signs that life might be present. Sometimes it is easy to feel small when you think about the size of the universe, but missions like Kepler remind us that being small does not mean we are alone. It means we are part of something far bigger than our one planet. It means that the quiet, star-filled sky above us might be full of other worlds, each with its own oceans, mountains, and maybe even its own dreamers, looking back. As you drift off tonight, imagine Kepler floating silently in space, its eye fixed on distant stars. Picture the planets circling those stars, hidden in the dark until a tiny dip of starlight gave them away. Somewhere out there, Among the billions of suns, another Earth might be spinning right now, waiting for us to discover it. And maybe, just maybe, someone is looking up from that world too, wondering if they are alone in the night. The Drake equation, when people ask if we are alone in the universe, it can feel like a question without an answer. We look up at the stars and wonder if someone is looking back, but the truth is that we still do not know for sure. There is no proof yet that life exists anywhere else. But more than 60 years ago, an astronomer named Frank Drake came up with a clever way to think about this big question. Instead of guessing wildly, he wanted to break the question into smaller pieces. He created what is now called the Drake equation. The Drake equation is not a magic formula that gives us a final answer. It is more like a thought experiment that helps us see all the things that must come together for intelligent life to exist and for us to find it. By looking at each part, scientists can see where we have solid information and where we still have big gaps in our knowledge. The equation itself looks complicated at first, but its idea is simple. It asks us to think step by step about what needs to happen for there to be civilizations out there that we might hear from or talk to someday. The first part is the rate at which new stars form in our galaxy. Right now, astronomers estimate that about 1 to 3 new stars are born each year in the Milky Way. That might sound slow, but over millions of years, it adds up to countless new suns shining in the dark. Next, the equation asks what fraction of those stars have planets. In Frank Drake's time, this number was mostly a guess because no one had ever seen an exoplanet. But today, thanks to missions like Kepler, we know that planets are common. Most stars probably have at least one, and many have whole families of planets circling them. So this part of the equation gives us hope. The raw materials for life are not rare, but not every planet is in the right place. The next factor is how many of those planets could support life. This is where the Goldilocks Zone comes in. A planet must be at the right distance from its star, with temperatures that allow water to stay liquid. It must also have the right size, the right kind of atmosphere, and a stable orbit. Some planets might be too hot or too cold. Others might have poisonous gases or no atmosphere at all. But even if only a small fraction are just right, the number could still be huge when you think about all the stars out there. After that, Drake's equation asks what fraction of those habitable planets actually develop life. This is one of the biggest mysteries. We know life formed here on Earth, but we do not know how easy or hard it was. Did life begin quickly because the conditions were perfect, or was it a 1 in a billion chance that took just the right spark? Scientists look at ancient rocks on Earth and see signs that life may have started as early as it could. That makes some believe that when conditions are right, life may be quick to appear. But life itself is just the beginning. The next step is to ask how many planets with life go on to develop intelligent beings. After all, Earth was home to simple cells for billions of years before anything like humans showed up. Dinosaurs ruled the planet for millions of years, but they did not build telescopes or send signals to space, so intelligent life could be much rarer than simple life. Then, the equation asks what fraction of intelligent life can create technology that sends signals into space. Humans have been doing this for just over a century. We send radio waves, television broadcasts, and other signals that spread out through space. But even now, our signals are faint compared to the distances they must travel. If a civilization never builds this kind of technology, or chooses not to, we may never know they exist. The final piece is about time. How long do these civilizations last? Do they survive for thousands of years, or do they disappear quickly? If civilizations are short-lived, the odds of two existing at the same time go down. This is one reason why the question feels so big. Even if life forms easily, even if intelligence grows often, our window to find each other may be small. When Frank Drake first shared his equation in 1961, he did not expect people to find a single answer. He hoped it would help scientists see what questions to ask. It sparked new ideas and led to the search for signals through programs like SETI, the search for extraterrestrial intelligence. Today, the equation still reminds us that the search for life is not just about pointing our telescopes at the stars. It is about understanding how rare or common each step might be. So when you hear someone mention the Drake equation, remember it is not just a string of numbers. It is a way to see the universe with fresh eyes. It reminds us that every star you see might have planets. Some of those planets could have oceans and air. Some could have simple microbes swimming in warm seas. And somewhere maybe there is intelligent life looking up at the stars, trying to find out if they are alone too. As you drift off tonight, think about those quiet numbers adding up in the dark. One star, then two, then billions more. Planets orbiting gently, life trying to take hold, minds wondering and sending signals out into the endless night. The Drake equation may not give us a final answer yet, but it keeps our curiosity alive, and maybe one day it will guide us to a voice calling back through the stars. The Fermi Paradox. Sometimes a question is so simple that it stays with you long after you hear it. More than 70 years ago, a famous physicist named Enrico Fermi asked a question that still puzzles scientists today. He looked at the stars, thought about the size of the universe, and said, "Where is everybody?" This question became known as the Fermi Paradox. It is one of the biggest puzzles in the search for life beyond Earth. The idea behind the Fermi Paradox is easy to understand. If the universe is so big, and there are billions of stars with planets that could hold life, then why have we not found any signs of it yet? Why is there so much silence in the night sky when the math says the galaxy should be full of life? When Enrico Fermi asked his question in 1950, people were only beginning to understand how big the universe really is. Back then, we did not know about exoplanets or how common they are. Now, thanks to missions like Kepler, we know that planets are everywhere. We also know that some of these planets sit in the Goldilocks Zone, where conditions might be just right for life. The Drake equation shows us that the odds of life out there should be pretty good if we look at the numbers alone. So why does it feel so quiet? This gap between what we expect and what we actually see is the heart of the Fermi Paradox. It is sometimes called the Great Silence. It is the strange feeling that comes from looking up at the stars and realizing that so far we have not seen any clear sign that we have company. Scientists have come up with many ideas to explain the Fermi Paradox. Some ideas are simple. Maybe intelligent life is just very rare. Maybe life itself is common, but it usually stays small and simple, like bacteria. It might be that most life never grows into civilizations that can send signals or build spaceships. Earth was home to single-celled life for billions of years before anything complex appeared. Even today, humans are the only species on our planet that can send messages into space. Other ideas suggest that intelligent life may destroy itself before it can reach out to the stars. Civilizations might develop powerful technology, but then use it in ways that lead to their own end. If most advanced civilizations do not last long, the chances that two exist at the same time become very small. The galaxy might be full of ruins and lost signals, but we would not know because we have not found them yet. Another explanation is that space is simply too big. Even if there are thousands of civilizations out there, They could be so far apart that it takes centuries or even thousands of years for signals to cross the distance. By the time a signal reaches us, the civilization that sent it might be gone. Our own radio signals have only been traveling through space for about 100 years. That means they have reached a bubble about 100 light years wide. In cosmic terms, that is like a single grain of sand in an ocean. Some scientists also wonder if we are looking for the wrong kind of signals. We search for radio waves because that is the technology we know. But an advanced civilization might use technology we cannot even imagine. They might use lasers, gravitational waves, or something beyond our understanding. If so, their signals could be passing right by us without us noticing. There are also ideas that sound like something from a science fiction story. Some people wonder if there could be civilizations that choose to stay hidden. They might watch the universe quietly, like an ancient forest where the animals stay silent to avoid danger. This idea is called the zoo hypothesis. It suggests that Earth could be like an exhibit in a cosmic zoo, with advanced beings choosing not to disturb us. Of course, there is no proof of this, but it shows how wide our imagination can stretch when faced with silence. The Fermi Paradox does not mean we should stop looking. In fact, it inspires scientists to keep searching. It reminds us that the universe is full of questions we have not answered yet. New telescopes listen for faint radio signals and search the skies for planets that could hold life. Space missions visit distant moons and probe ancient ice for signs of tiny living things. Each discovery brings us closer to understanding whether the Great Silence is real or just the result of us not knowing how to listen yet. For now, the night sky stays quiet, but maybe that will not always be true. Maybe one day we will pick up a signal that cannot be explained by a star or a galaxy or a natural burst of energy. Maybe one day we will know that somewhere out there, another mind looked at the stars and asked the same question we do: where is everybody? As you drift off to sleep tonight, think about that quiet question echoing through the dark. The stars above you are part of a vast ancient ocean. Somewhere in that ocean, there may be other voices waiting to be heard. Until then, we keep listening, keep wondering, and keep dreaming that one day the silence will break. The origins of life on Earth. When we look up at the stars and ask if we are alone, we always come back to the same place: Earth. So far, our own planet is the only place in the universe where we know for certain that life exists. Every tree, every fish, every person you have ever known is part of this single living story. But how did life begin here in the first place? This question is one of the greatest mysteries science still tries to solve. The Earth formed about 4.5 billion years ago. In those early days, our planet was a harsh place. Volcanoes poured out lava and gas. Asteroids and comets bombarded the surface. The air was thick with carbon dioxide, methane, and ammonia, nothing like the fresh air we breathe today. There were no green plants, no animals, not even the simplest bacteria, just rock, water, and the raw ingredients that might one day become life. Scientists believe life began sometime around 3.5 to 4 billion years ago. That means life has been part of Earth's story for most of its existence. The question is, how did it happen? How did non-living chemicals come together to form something that could grow, reproduce, and evolve? One of the most popular ideas is that life started in a kind of chemical soup. Back then, Earth's oceans were full of simple molecules like water, methane, ammonia, and hydrogen. Lightning, volcanic heat, and ultraviolet rays from the sun may have sparked chemical reactions that built more complex molecules, including amino acids, which are the building blocks of proteins. In the 1950s, a famous experiment by Stanley Miller and Harold Urey showed that when you mix these gases and add a spark, you can make amino acids in the lab. This simple experiment gave scientists hope that life's first ingredients could form naturally. But making building blocks is only the first step. Life also needs a way to store information and copy itself. Today, all living things use DNA or RNA to carry genetic information. Some scientists think that before DNA, early life may have used simple strands of RNA to store instructions and help chemical reactions happen faster. This idea is known as the RNA world hypothesis. Another clue comes from some of Earth's most extreme places, the deep ocean. Far below the surface, where sunlight never reaches, there are cracks in the seafloor called hydrothermal vents. These vents gush out hot, mineral-rich water. Around these vents, entire ecosystems thrive, with strange creatures like tube worms and giant clams living in total darkness. The heat and minerals create conditions where chemicals can react in ways they might not on the cold ocean floor. Some scientists think that life may have first formed in places like these, protected from harsh sunlight and bombarding space rocks, with all the right ingredients swirling in the warm, mineral-rich water. But there is another idea that adds an even bigger twist. What if the first spark for life did not come from Earth at all? This idea is called panspermia. It suggests that the building blocks of life, or even tiny living cells, might have traveled to Earth from somewhere else in space. We know that some meteorites contain amino acids and other organic molecules. We also know that some bacteria on Earth can survive in extreme conditions, like freezing temperatures and the vacuum of space. It is possible that comets or asteroids carried these pieces through space and delivered them to early Earth. If this happened, it would mean that life's story began not just here, but out there in the wider universe. No matter which idea is true, the origins of life show us something important. Life is tough and surprising. Once it took hold on Earth, it adapted to almost every environment you can imagine. Microbes live in boiling hot springs, deep underground, and frozen glaciers. Tiny life forms have even been found inside rocks and near underwater volcanoes, where temperatures and pressures would kill most other creatures. These extremophiles, life forms that thrive in extreme conditions, remind us that if life could survive in such harsh places here, maybe it could do the same on other planets or moons. Understanding how life began also helps scientists decide where to search for life elsewhere. They look for places with water, warmth, and the right mix of chemicals. They study icy moons like Europa and Enceladus, which may have oceans under their frozen shells, heated by the pull and squeeze of gravity. They examine Mars, which may have once had lakes and rivers, and where signs of ancient life could still be hidden in the rocks. Our own planet is still our best laboratory for these questions. Every fossil, every tiny microbe, every drop of water carries a clue. And though we still do not have all the answers, each discovery brings us closer to understanding the amazing chain of events that turned a lifeless world into a living one. As you drift off to sleep tonight, think about those early oceans, full of strange chemicals swirling under a young sun. Picture tiny bubbles of life forming in the deep, protected by warm vents or drifting through ancient tides. From those first simple cells grew forests, fish, dinosaurs, and at last people like you, still looking up at the stars and wondering if life's miracle happened somewhere else too. Extremophiles, Earth's tiny aliens. When we imagine life on other planets, We often picture something big and strange, maybe huge creatures with tentacles or glowing eyes. But the truth is, if we ever find life beyond Earth, it will probably look more like the smallest life we have here. It might be tiny, simple, and hard to see without a microscope. To understand what life might be like elsewhere, scientists look at some of the toughest, tiniest life forms right here at home. These incredible survivors are called extremophiles. The word extremophile means lover of extremes. These are tiny organisms, mostly bacteria and single-celled microbes, that live and grow in places that would kill most other living things. They stretch our ideas of where life can survive and remind us that life is far more adaptable than we once thought. Some extremophiles live deep beneath the ocean, where sunlight never reaches. Around hydrothermal vents on the ocean floor, the water is superheated by the Earth's core. Temperatures can rise above 700 degrees Fahrenheit. Here, chemical-rich water gushes out into the frigid sea. You might expect these places to be lifeless, but instead they are home to entire communities of microbes that feed off chemicals like hydrogen sulfide. These microbes form the base of a food chain that includes giant tube worms, clams, and crabs. Without sunlight, these tiny bacteria create energy through a process called chemosynthesis. They show us that life does not always need sunlight to survive. Other extremophiles thrive in places that are cold and frozen. Scientists have found tiny bacteria living in glaciers, frozen lakes, and even deep within Antarctic ice sheets. Some of these microbes survive by going dormant for long periods. They slow down their life processes so much that they can last thousands or even millions of years, frozen in ice until conditions improve. This gives scientists hope that life could survive on icy worlds like Europa or Enceladus, moons that have oceans hidden beneath their frozen shells. There are also extremophiles that love acid. In places like acidic hot springs or acid mine drainage, the water is so sour it would burn your skin. Yet certain bacteria not only live there, but actually need that acid to grow. Others survive in lakes full of salt, far saltier than any ocean. One example is the Dead Sea, where salt-loving microbes turn the water red or pink during certain times of the year. And then there are the radiation lovers. Some microbes can survive levels of radiation that would be deadly to humans. For example, the bacterium Deinococcus radiodurans is often called Conan the bacterium because it can survive radiation doses thousands of times higher than what would kill a person. It can also survive dehydration and extreme cold. Scientists think its remarkable survival skills could offer clues to how life might survive harsh conditions on Mars or even in the vacuum of space. Extremophiles are not just interesting to study, they have changed how we look for life beyond Earth. For a long time, scientists focused on finding planets that look just like Earth, with mild temperatures, liquid water, and gentle weather. But extremophiles show us that life can adapt to places that seem impossible. This means we can look at a wider range of places when we search for alien life. When missions search for signs of life on Mars, they look in places like dried-up riverbeds and ancient lake beds, but they also look under rocks and deep underground, where microbes could hide from radiation and freezing temperatures. On icy moons like Europa and Enceladus, scientists hope to someday drill through thick ice to reach the warm, salty oceans below, where heat from the moon's core could create hydrothermal vents, just like the ones on Earth's ocean floor. Even on our own planet, extremophiles help us discover new things about life's potential. Some of their enzymes and proteins are used in medicine and industry. The heat-loving bacteria that thrive in hot springs, for example, provided the special enzyme that makes DNA testing possible. Scientists study extremophiles to learn how life might survive the harsh journey through space, traveling on meteorites or comets from one world to another. Every time we find a new extremophile, we expand our idea of where life can live. It is no longer just the warm green places that count. It is the boiling, frozen, acidic, salty corners of our world too. These tiny survivors remind us that life is incredibly creative. It finds a way to hang on, even when conditions are harsh and lonely. So tonight, as you drift off to sleep, think about these tiny aliens that live all around us, hidden in places we would never think to look. Picture them clinging to rocks deep below the sea, resting in frozen lakes, or floating in salty pools under a burning sun. They are proof that life is tougher and more surprising than we ever imagined, and they give us hope that somewhere out there, other tiny survivors may be waiting to be found. DNA and universal building blocks. When we think about what makes life possible, we often imagine oceans, sunlight, and green plants. But at its heart, life comes down to tiny building blocks that are much smaller than anything we can see with our eyes. These building blocks are simple molecules that can join together to create more complex ones, like DNA. DNA is the special molecule that carries the instructions for life. It is like a recipe book that tells each cell how to grow, divide, and do its job. But where did these building blocks come from in the first place? Scientists have learned that the most basic parts of life, things like amino acids, can form in places that have never known a drop of rain or a ray of sunlight. Amino acids are small molecules that connect like beads on a string to build proteins. Proteins do nearly everything inside living things. They help build muscles, carry oxygen in our blood, and fight off diseases. Without amino acids, there could be no proteins, and without proteins, there could be no life as we know it. One of the most amazing clues about how common these building blocks might be came from space. In 1969, a meteorite fell near a small town in Australia called Murchison. When scientists collected pieces of this rock, they found something that seemed impossible at the time. Inside the meteorite were dozens of different amino acids. Some of these were the same kinds we find in living things on Earth. Others were new, never seen in nature before. The Murchison meteorite showed the world that the basic ingredients for life could form far from our planet in the cold, dark regions of space. This discovery changed how scientists think about life's beginnings. If amino acids can form on rocks drifting between the stars, they could have hitched a ride on asteroids or comets and arrived on Earth long ago. In Earth's early days, our young planet was bombarded by countless space rocks. Each one might have carried tiny seeds of organic molecules. Over millions of years, these seeds could have collected in Earth's warm oceans, creating the chemical soup that helped life begin. The Murchison meteorite is not the only proof we have. Other meteorites have also been found to contain amino acids and other organic molecules. In 2004, a mission called Stardust captured tiny bits of a comet called Wild 2. When the samples came back to Earth, scientists found glycine, the simplest amino acid, inside the comet dust. This was more evidence that space is not empty of life's ingredients. Instead, it seems to be full of them, drifting in dust clouds, hiding in icy comets, and clinging to ancient meteorites. Even in the vast clouds of gas and dust between the stars, what astronomers call interstellar clouds, we have found simple organic molecules. Using powerful radio telescopes, scientists have detected things like formaldehyde, methanol, and even more complex carbon chains. These molecules can stick together in cold, dark places where sunlight never shines. They show us that the universe naturally cooks up the parts needed for life, scattering them far and wide. DNA itself is more complicated than a simple amino acid, but its pieces can come from the same raw materials. DNA is made up of 4 chemical bases: adenine, thymine, cytosine, and guanine. These bases connect in pairs to form the famous double helix shape. Scientists have shown in laboratory experiments that these bases, or at least the chemicals needed to make them, can form under conditions that mimic space or early Earth. All this makes some scientists wonder if life's building blocks are truly universal. Maybe the same chemistry that happened on Earth could happen on other planets or moons. If amino acids can survive a trip through space on a meteorite, maybe they could seed life wherever they land, on Mars, on icy moons like Europa, or even on planets circling distant stars. This idea is called panspermia. It does not say that little aliens flew here in spaceships. Instead, it means that life, or at least its ingredients, could travel naturally from one place to another. It paints a picture of the universe as a garden where seeds drift on the solar wind, waiting to find just the right soil to grow. It also changes how we look for life elsewhere. When we send probes to other worlds, we do not just look for big signs like cities or forests. We look for the small clues: amino acids in Martian soil, organic molecules in the plumes of Enceladus, or hints of life's building blocks drifting in the atmosphere of faraway planets. So tonight, as you get ready to drift off to sleep, remember that every living thing, no matter how big or small, is built from these tiny pieces. Picture ancient comets racing through space, carrying a precious cargo of molecules that might one day help life bloom on another world. The building blocks that make you who you are could be sprinkled across the galaxy, waiting for the right spark to bring them together once more. The universe, it seems, is not just a place of stars and planets. It is also a place where the seeds of life are always ready to take root. Mars meteorites, ancient fossils. When we think about searching for life beyond Earth, Mars is often the first place that comes to mind. It is our closest neighbor that might once have had conditions similar to our own. For years, scientists have wondered if Mars was ever warm and wet enough for life to take hold. Dry riverbeds, ancient lake beds, and signs of old floods hint that long ago, Mars might have been more like Earth than it is today. But what if a clue to life on Mars was already here on Earth, hidden inside a piece of rock that traveled millions of miles to get here? One of the most famous space rocks ever found is called ALH 84001. This strange name stands for Allen Hills, the place in Antarctica where it was discovered in 1984, plus its collection number. It is a chunk of ancient Martian rock that was blasted off the surface of Mars by a powerful impact, probably from an asteroid strike, millions of years ago. Over time, this piece drifted through space until it finally fell to Earth and landed in the icy fields of Antarctica, where scientists later found it. What makes ALH 84001 so special is not just that it came from Mars, but what some researchers claim it might contain. In the 1990s, a team of NASA scientists, led by David McKay, announced something astonishing. They said that inside this little meteorite were tiny shapes that looked like fossilized bacteria. These microscopic features looked like tiny worm-like forms, similar in shape to bacteria found here on Earth. The team also found chemical signs called polycyclic aromatic hydrocarbons, or PAH, which can be linked to the breakdown of living things. Their discovery sparked headlines around the world. Some newspapers called it the first real proof that life existed on another planet. Even the President of the United States at the time gave a speech about it, saying that this tiny rock might change how we see ourselves in the universe. But not everyone agreed with this bold claim. Right from the start, other scientists pointed out that the evidence was not clear-cut. The shapes inside the rock were so small that they were smaller than many bacteria found on Earth. Some argued that these tiny shapes could have formed through natural chemical processes that had nothing to do with life. Others suggested that the chemical traces could have come from contamination after the rock landed on Earth. The debate over ALH 84001 became one of the biggest scientific arguments about life beyond our planet. Over the years, new studies have looked at this meteorite again and again. Some researchers have found new ways to test the rock using better microscopes and more advanced chemistry. Some studies still find hints that look like they could be signs of ancient Martian microbes. Others find more evidence that the shapes are likely just mineral formations, created when the rock sat underground in Mars's crust for millions of years. One of the biggest challenges is that ALH 84001 is billions of years old. The rock formed on Mars about 4 billion years ago, at a time when Mars may have had liquid water on its surface. Since then, it has been through so much: impacts, ejection into space, drifting for ages, then crashing through Earth's atmosphere. All that time, it could have picked up tiny bits of Earth life, changing the story the rock has to tell. Separating what might have happened on Mars from what happened here is very difficult. Still, ALH 84001 taught scientists an important lesson. It showed that clues about life might not just be found on Mars itself, but could arrive here, hand-delivered by nature. This idea keeps researchers interested in other Martian meteorites too. In fact, we have found more than 300 Martian meteorites on Earth so far. Some come from Antarctica, others have been picked up in deserts, where their dark surfaces stand out against pale sand. Each new rock is a tiny time capsule from Mars. They hold information about Mars's ancient volcanoes, its watery past, and maybe, just maybe, tiny hints about whether life ever took hold there. While we wait for missions to bring fresh samples back from Mars, these space rocks are the best clues we have. The debate over ALH 84001 has pushed science forward in other ways too. It helped inspire plans for rovers and landers to drill into Martian rocks and search for signs of life right at the source. It showed that we need careful tools and clean labs to avoid contamination, so we do not mistake an Earth germ for a Martian one. So far, no one has found proof that life ever existed on Mars, but each discovery, each rock reminds us that answers could be waiting right under our feet, tucked away in the oldest stones we find. And one day, maybe soon, we will hold a piece of Mars in our hands again, this time freshly gathered by a rover and carefully carried home, ready to tell its ancient story. As you drift off to sleep tonight, imagine that tiny piece of Mars resting on a lab table here on Earth. Picture the scientists peering through microscopes, wondering if those tiny shapes are just rocks or the ancient fossils of long-lost Martian life. The answer might still be locked inside that stone, waiting for a curious mind to unlock its secrets. And maybe, when we finally know the truth, we will see that we were never truly alone after all. Water, water everywhere, everywhere, tonight near you Hudneri, Prudside Breksh, Port Nixbiri, tonight Nidrija Sturasbord the Retib. When scientists look for life beyond Earth, they start with one simple question: is there water? That is because every living thing we know needs water to survive. Our bodies are made mostly of water. Plants draw water up through their roots. Animals drink water or get it from the food they eat. Even tiny microbes need water for the chemical reactions that keep them alive. Without liquid water, life as we know it would not exist. Earth is sometimes called the blue planet because so much of its surface is covered by oceans, lakes, and rivers. From space, Earth looks like a shimmering marble wrapped in blue. For a long time, we thought our world was special in this way. Other planets in our solar system seemed too dry, too hot, or too cold to hold liquid water. But in the last few decades, new discoveries have changed our thinking. We have learned that there may be much more water out there than we ever imagined. Some of it is hidden deep below thick layers of ice, locked away in secret oceans that could hold the ingredients for life. One of the most exciting places is Europa, one of Jupiter's largest moons. From the outside, Europa looks like a frozen world, covered in smooth, cracked ice. But when scientists looked closer, they saw hints that something amazing lies beneath. The ice that covers Europa might be miles thick, but underneath that ice is likely an ocean of salty water. This ocean could be twice the size of all the oceans on Earth combined. Heat from inside Europa, caused by the moon being pulled and squeezed by Jupiter's strong gravity, may keep the water from freezing solid. This same process, called tidal heating, could create underwater vents on Europa's ocean floor, places where life could find warmth and food, just like around Earth's deep-sea vents. Then there is Enceladus, a small moon of Saturn. When the Cassini spacecraft flew by Enceladus, it saw something surprising: huge plumes of water vapor shooting out from cracks near the moon's south pole. These icy geysers come from an underground ocean that lies beneath the frozen crust. The plumes carry tiny bits of salt and simple organic molecules, the same kinds of building blocks that are so important for life. Some scientists believe that if we could fly a spacecraft through those plumes and collect samples, we might find signs of tiny living things, or at least the chemistry that life needs to get started. Another fascinating place is Titan, Saturn's largest moon. Titan is different because it does not just have water hidden underground. It also has lakes and rivers on its surface, but they are not filled with water like ours. Instead, they are made of liquid methane and ethane, which are gases on Earth, but stay liquid on Titan because it is so cold. Titan's surface is bitterly cold, far below freezing, but its thick atmosphere and liquid lakes make it one of the most Earth-like places we have found so far. Some scientists wonder if life could use methane the way we use water, creating a kind of alien life that is truly different from anything we know. These icy moons show us that water and the potential for life may be hiding in places we once thought were dead and frozen. Beneath miles of ice, warmth and liquid water can exist side by side, and where there is liquid water, there is hope that life might find a way. Finding water is also important because it gives us clues about a world's history. Mars, for example, has no oceans today, but dry riverbeds and signs of ancient lakes tell us that water once flowed freely there. Even now, frozen water ice sits at Mars's poles and beneath its surface. Some scientists believe that salty brines could still flow underground during certain times of the year. If so, tiny microbes could be hiding there, waiting for us to find them. Looking for water helps guide the missions we send to other worlds. Future spacecraft will drill through Europa's thick ice or fly through Enceladus's plumes, collecting tiny droplets and bringing them back for study. Rovers on Mars search for signs that water was once there in large amounts. Even telescopes look at faraway planets around other stars, searching for hints of water vapor in their atmospheres. Each discovery brings us closer to understanding how common water really is and how many chances life might have had to begin. Water shapes our search for life because it is the key that unlocks so many other things. It dissolves nutrients, carries energy, and helps create the conditions that tiny life needs to survive. Here on Earth, we find life everywhere there is water, from the deepest ocean trenches to tiny droplets inside rocks. If life could find a foothold in these places here, then maybe it could do the same on a distant moon or faraway planet. So tonight, as you close your eyes and drift to sleep, think of the hidden oceans deep beneath Europa's ice, the bright geysers of Enceladus spraying into space, and Titan's cold, dark lakes under an orange sky. Picture tiny worlds where water waits, quietly holding the secrets of what might be swimming, growing, or drifting in the dark. Somewhere out there, the story of water may also be the story of life, ready to be discovered by those who dare to look. Europa, the salty moon. Far away from Earth, circling the giant planet Jupiter, is a small frozen world named Europa. From the outside, Europa does not look like the kind of place you would expect to find clues about life. Its surface is covered in smooth, bright ice, streaked with dark lines that make it look like a cracked eggshell floating in space. There are no forests or oceans to see, just miles and miles of frozen crust. But underneath that icy shell, scientists believe is one of the most promising places in our solar system to search for life. Europa is slightly smaller than our own moon, but it holds something amazing deep below its surface, an ocean of salty, liquid water. This ocean is not just a shallow pond. It may be up to 60 miles deep and could hold twice as much water as all of Earth's oceans combined. That makes Europa one of the biggest bodies of liquid water we know of anywhere in the solar system. And where there is water, there is hope that life could survive. How do we know that Europa's ocean exists if it is hidden under all that ice? Clues have come from many different missions that have flown by Jupiter and its moons. The Galileo spacecraft, which explored Jupiter in the 1990s and early 2000s, sent back data showing that Europa's icy surface is moving and shifting. Some parts look like broken puzzle pieces that have drifted apart and frozen again. This suggests that the ice floats on top of something liquid. Galileo also found that Europa has a magnetic field that hints at a salty, moving ocean below. The salt in the water helps carry electric currents, which create this field. One of the most exciting pieces of evidence came more recently. In 2012, the Hubble Space Telescope spotted huge plumes of water vapor shooting up from Europa's surface. These plumes reach more than 100 miles into space. Scientists think they come from cracks in the ice that connect to the ocean below. Just like the geysers on Earth shoot steam and hot water into the air, Europa's plumes spray salty water into space. This is important because it means we might be able to sample the ocean without even having to drill through the ice. NASA and other space agencies are planning missions that will take a closer look at this salty moon. One of the most exciting is the Europa Clipper mission, which is being built right now. The Europa Clipper is set to launch in the coming years and will orbit Jupiter, making dozens of close flybys of Europa. It will carry a suite of instruments designed to study Europa's ice shell, the ocean beneath, and the plumes that rise from its surface. The Europa Clipper will use powerful cameras to map the surface in great detail. It will use ice-penetrating radar to measure the thickness of the ice and look for pockets of water. Instruments will analyze the particles in the plumes to see what kinds of salts, minerals, and organic molecules they contain. If the plumes have complex chemicals linked to life, it would be one of the biggest discoveries in history. Another mission idea for the future is to land directly on Europa's surface. A lander could drill or melt its way through the ice, sending instruments down to sample the ocean below. This is a huge challenge because of the thick ice and the radiation that surrounds Jupiter, but the rewards could be worth it. Finding even simple microbes in Europa's ocean would prove that life is not unique to Earth. One reason Europa's ocean is so exciting is that it may be similar in some ways to parts of Earth's oceans. On our planet, life thrives around deep-sea hydrothermal vents. These vents release heat and minerals from inside the Earth, creating an environment where microbes and other strange creatures survive without sunlight. Some scientists think Europa's ocean could have similar vents on its seafloor. If it does, these warm, mineral-rich spots could give life a chance to develop, even though the surface is frozen and dark. Europa also shows us how dynamic and surprising our solar system can be. For centuries, we thought that life could only exist on planets like Earth, warm, with liquid water on the surface and sunshine to provide energy. But moons like Europa challenge that idea. They show us that oceans can hide beneath ice, warmed by the push and pull of gravity. They remind us that life might find a way in places we once thought were too cold and empty. So tonight, as you settle under your blankets and close your eyes, picture that tiny moon circling faraway Jupiter. Imagine cracks in its icy shell, glowing faintly as plumes of salty vapor burst through, spraying bits of an alien ocean into the blackness of space. Somewhere down in that hidden ocean, there could be tiny swimmers drifting through the dark, proof that life can bloom in even the coldest corners of the solar system. And one day, when our spacecraft reach that frozen world, we might finally hear what its secrets have to say. Enceladus, geysers of potential. If you asked someone where they thought we might find signs of life in our solar system, they might mention Mars, or maybe Jupiter's moon Europa. But one of the most surprising and promising places to look is a tiny, icy moon that orbits Saturn. Its name is Enceladus. From far away, Enceladus looks like a small frozen snowball drifting through space. It is only about 300 miles wide, much smaller than Earth's moon. But despite its small size, Enceladus holds one of the most exciting secrets we have discovered so far. For a long time, Enceladus was just one of Saturn's many moons, not a place most people paid much attention to. That changed in the early 2000s when the Cassini spacecraft arrived at Saturn. Cassini was a big mission that gave us our best look yet at Saturn, its rings, and its many moons. When Cassini flew by Enceladus, it found something amazing. Near the moon's south pole, it spotted huge plumes of water vapor shooting into space. These plumes were not small. They stretched hundreds of miles above the moon's surface, like giant icy fountains spraying into the blackness. Scientists soon realized that these plumes came from cracks in the moon's icy crust. The cracks, sometimes called tiger stripes because of the way they look, let water escape from an ocean hidden beneath the ice. This discovery was surprising because Enceladus is so small. A moon that size should be frozen solid, but instead, something is keeping its ocean liquid. The answer is the same tidal heating that warms Europa's ocean. Saturn's gravity pulls and squeezes Enceladus as it orbits, creating friction and heat inside the moon. This heat keeps water from freezing completely and may even create warm spots at the ocean floor, just like the hydrothermal vents we find deep in Earth's oceans. What makes Enceladus even more interesting is what Cassini found inside the plumes. When the spacecraft flew through them, its instruments detected tiny grains of ice that contained organic molecules, the same basic building blocks of life that we find on Earth. These included simple carbon-based compounds and even more complex ones that can form parts of amino acids. The plumes also had salts and silica, which suggests that the water inside Enceladus is not just cold and still, but moving and interacting with rock. This is important because here on Earth, some of the oldest and strangest forms of life live around hydrothermal vents on the ocean floor. These vents release hot, mineral-rich water. Even in total darkness, bacteria thrive around them, using the chemicals in the water to create energy. Tiny shrimps, tube worms, and other weird creatures gather around these vents, living off the heat and minerals instead of sunlight. If Enceladus has similar vents on its seafloor, then its ocean could have the same kinds of warm, chemical-rich environments where life might find a foothold. What makes Enceladus so special is that we do not have to drill through miles of ice to reach its ocean. Its geysers do the hard work for us. They spray tiny droplets of ocean water out into space, where a spacecraft can fly through them and collect samples. Cassini did exactly that. It tasted the plumes and gave us our first clues that Enceladus's ocean could be more than just salty water. Future missions could fly through these plumes again, using even better instruments to search for more complex molecules or signs of tiny living things. NASA and other space agencies have talked about new missions that could visit Enceladus again. Some ideas include orbiters that would circle the moon and fly through its plumes many times, gathering more data. Others dream of sending a lander that could touch down near the cracks and study the geysers up close. Some scientists even imagine a tiny robot submarine that could dive beneath the ice and explore the ocean directly, though this would be a huge challenge. Enceladus also teaches us something important about our search for life. It shows that we should not only look at big planets or warm Earth-like places. Sometimes the most hopeful places are small worlds in the coldest parts of our solar system. It reminds us that life can hide in places we once thought impossible, warmed not by sunlight, but by the heat deep inside. So tonight, as you drift off to sleep, picture Enceladus far away in the dark, circling Saturn with its hidden ocean deep below the ice. Imagine its geysers spraying salty mist into space, carrying tiny clues about what might swim in its secret sea. Maybe, right now, tiny microbes drift near a warm vent on Enceladus's ocean floor, never knowing that somewhere out there, people are dreaming of finding them. In those plumes of ice and salt, we might someday find the proof that life does not belong only to Earth, but to many small, hidden corners of the universe. SETI, the Cosmic Listening Post. For as long as people have looked up at the stars, they have wondered if someone else might be out there looking back. We have built telescopes to see distant planets, sent probes to explore the far reaches of our solar system, and studied rocks that fell to Earth from space. But one of the most fascinating ways we search for life is by simply listening. This is the heart of SETI, which stands for the Search for Extraterrestrial Intelligence. SETI is not just one project or telescope. It is an idea and an effort that has brought together scientists from all over the world. Its goal is to scan the sky for signals that might come from intelligent beings. These signals would not be random noise like the hum of stars or the hiss of cosmic dust. They would be narrow and organized, standing out from the natural sounds of the universe, the kind of signal that suggests someone, somewhere, is sending a message. The idea behind SETI is simple. If we can send radio and television signals into space, maybe other civilizations can too. Maybe they have been doing it far longer than we have. Since the early 20th century, our own radio and TV broadcasts have been leaking into space like ripples in a pond. They travel at the speed of light, so right now, Our oldest signals have reached about 100 light years away. That is just a tiny bubble in our galaxy, but it shows that communication does not stop at our atmosphere. One of the first famous SETI experiments was done in 1960 by a scientist named Frank Drake. He pointed a radio telescope at two nearby stars and listened for anything unusual. He did not find any alien messages, but his work inspired generations of scientists to keep listening. Over the years, many SETI projects have used giant radio telescopes to scan the sky. Some listen to specific stars that might have planets. Others sweep wide areas of space, hoping to catch a signal from somewhere unexpected. Listening for these signals is not easy. Space is full of natural radio waves. Stars crackle and flare. Pulsars, which are spinning neutron stars, send out regular pulses that once confused astronomers who thought they might be artificial. Earth itself is noisy too. Our cell phones, satellites, and radar systems create signals that can bounce back into a telescope's ear, fooling scientists for a moment. Sorting through all this static takes time and patience. So far, SETI has found mostly silence. But every once in a while, there is a strange blip, a signal that makes people sit up and wonder if this is the message we have been waiting for. The most famous of these is called the WOW signal. In 1977, an astronomer named Jerry Amon was working at a radio telescope in Ohio. He saw a strong, clear signal that lasted for 72 seconds. It was so unusual that he wrote "wow" in the margin of the data printout. To this day, no one knows what caused it. It has never repeated. Some think it was a one-time signal from a distant source. Others believe it was an Earth-based interference that we did not understand at the time. But the WOW signal remains one of SETI's greatest mysteries. Other strange signals have popped up over the years. Fast radio bursts, or FRBs, are short but powerful pulses that come from deep space. They last only milliseconds, but pack as much energy as our sun produces in a day. Most scientists think they come from natural sources, like neutron stars or black holes. But a few people wonder if they could be some kind of cosmic beacon. So far, the evidence points to natural causes, but these odd bursts keep our curiosity alive. SETI is not just about big radio dishes anymore. Scientists now use computers and artificial intelligence to help search for patterns in all the noise. They share data around the world, letting people look for signals in new ways. Some programs, like ProcTED, even let anyone with a home computer help by using spare processing power to scan huge amounts of data for something unusual. This teamwork means that more eyes and ears are focused on the sky than ever before. Listening for alien signals also teaches us patience and wonder. The universe is big, and it may take decades or centuries before we hear anything at all. Maybe no one is close enough. Maybe civilizations rise and fall before their signals can reach us. Or maybe they are sending messages in a form we do not know how to recognize yet. But each year, we learn more about the kinds of signals that nature makes, and that helps us better understand what to look for. SETI reminds us that the search for life is not just about finding planets or microbes. It is about connection. It is about the hope that somewhere across the vast emptiness, another mind is trying to say hello. So tonight, as you close your eyes, imagine giant radio dishes turning quietly toward the stars. Picture tiny blips of data crossing endless space, carrying the possibility of an answer to a question we have asked for generations. Are we alone? Somewhere in the silence, maybe a signal waits for us to listen just a little bit longer. The WOW signal, Fairsignal, and love, Pymernetissold. When people talk about the search for life beyond Earth, They often mention the big things we can see: planets, oceans, and maybe even microbes in rocks. But sometimes the most powerful clues come from something we cannot see at all: a simple signal drifting through space. One of the most famous and mysterious signals we have ever found is known as the wow signal. Even though it lasted just a few seconds, this strange radio burst has become a legend among those who listen for voices in the stars. The story of the wow signal begins in 1977. Back then, a large radio telescope called the Big Ear stood quietly in a field in Ohio. This telescope was part of one of the first major efforts to listen for signs of alien life. It scanned the sky day and night, recording any radio waves that might stand out from the constant hum of natural noise that fills the universe. One night, on August 15th, the Big Ear picked up something unusual. A scientist named Jerry Amon was working with the data a few days later when he noticed a strong, clear spike in the radio signal. It was so different from the normal static that it caught his attention right away. In the margin of the printout, he grabbed a red pen and circled the strange numbers and letters. Next to it, he wrote one simple word: wow. That one word gave this signal its name, the wow signal. To this day, no one knows exactly what it was. What made it so interesting was that it looked exactly like what scientists expected to see if an intelligent source was sending out a narrow, focused radio transmission. It was strong. It lasted for 72 seconds, the maximum time the telescope could stay pointed at one spot before the Earth's rotation moved it on. Then it was gone. There was no noise before or after, no fading in or out. It came from a patch of sky near the constellation Sagittarius, in the direction of a group of stars called Chi Sagittarii. Scientists did not jump to conclusions. First, they asked whether the signal came from something on Earth. Maybe it was a secret military test, or a broadcast bouncing off space junk. But careful checks found no known source of interference. The signal came from the sky, not the ground. It was not the kind of frequency that Earth satellites or TV stations use. It sat close to what scientists call the hydrogen line, a frequency that is quiet and clear, one that many believe is a good choice if someone wanted to send a signal across the stars. After the wow signal, scientists pointed the Big Ear and other telescopes at that part of the sky many times, hoping to catch the signal again, but it never repeated. In science, repeating an experiment or observation is important. A one-time event is interesting, but without more data, it is hard to know what it means. Over the years, people have offered different explanations. Some think it was a rare kind of natural radio burst, maybe from a comet or a distant object we did not know about at the time. Others believe it really was a transmission from another civilization that just happened to pass by when we were listening. What makes the wow signal so special is not just the mystery, but what it represents. It shows that we are listening. It reminds us that sometimes the universe whispers back when we ask questions. The signal inspired new ideas in the field of SETI, the search for extraterrestrial intelligence. It taught scientists that signals could appear at any time, from anywhere in the sky, and that we have to be patient and ready to listen when they do. The wow signal also sparked the public's imagination. It shows up in books, documentaries, and even songs. For many people, it is a symbol of the hope that we are not alone. It is a tiny clue, a moment when the universe seemed to tap us on the shoulder and hint that there might be someone else out there trying to say hello. Today, the search continues with more advanced telescopes and better technology. New projects scan the sky all the time, gathering mountains of data and using computers to look for patterns that might mean someone is calling across the stars. Even though we have not found another wow signal yet, we keep listening. Scientists know that the universe is huge and the chances of finding a signal are small, but the payoff, proving that we share this universe with other intelligent life, would be one of the greatest discoveries in human history. So tonight, as you drift off to sleep, picture that lonely signal, a whisper from the darkness that lasted just 72 seconds. Imagine it traveling across light years, crossing empty space, and brushing past Earth like a breeze you barely feel. It might have been a coincidence, a trick of nature, or it might have been the first word in a conversation waiting to be finished. The wow signal is a reminder that the universe still holds secrets and that sometimes all we have to do is listen. Mysterious FRBs, fast radio bursts. The universe is full of signals that we can hear if we know how to listen. Some of these signals come from things we understand well: stars that pulse regularly, black holes that gobble up matter, or even the background hiss left over from the Big Bang. But sometimes our telescopes catch signals that make us pause and scratch our heads. One of the strangest and most exciting of these signals is something called a fast radio burst, or FRB for short. FRBs are exactly what their name suggests. They are bursts of radio waves that flash across space in a brief but powerful signal. Each one lasts only a few milliseconds, just a thousandth of a second, but in that blink of time, they can release as much energy as the sun does in a whole day. Imagine all the light and heat from our sun packed into a signal so quick you would miss it if you blinked. That is what makes FRBs so fascinating. The first FRB was discovered by accident in 2007. A scientist named Duncan Lorimer and his student were going through old data from a radio telescope in Australia when they found something strange, a sudden bright flash of radio waves that seemed to come from far outside our galaxy. No one had ever seen anything quite like it before. At first, some people wondered if it was just a glitch or some interference from Earth. But soon, more of these bursts started to show up in other telescope data. Since then, astronomers have found hundreds of FRBs. Most of them appear once and then never repeat. They flash for a moment and are gone forever, leaving behind only a faint trace in the data. Others, though, are more mysterious because they do repeat. These repeating FRBs burst out again and again, sometimes following patterns, sometimes not. One of the best-known repeaters is called FRB 121102. It was discovered in 2012, and since then, it has sent out hundreds of bursts. Scientists have even managed to track it back to a small, faint galaxy, billions of light years away. So what causes these powerful, millisecond-long signals? That is the big question. No one knows for sure, but there are some good ideas. One possibility is that FRBs come from neutron stars. Neutron stars are what is left after a massive star explodes in a supernova. They are tiny and incredibly dense. A teaspoon of neutron star material would weigh as much as a mountain. Some neutron stars are called magnetars because they have magnetic fields trillions of times stronger than Earth's. A magnetar might twist and crack, sending out a burst of energy that we see as an FRB. Other ideas suggest that FRBs could come from black holes pulling in matter, or from stars colliding far out in the universe. Some theories even suggest more exotic explanations, like cosmic strings, thin, high-energy defects in the fabric of space-time. These ideas sound like something out of science fiction, but they help scientists think about all the ways the universe could surprise us. And of course, some people wonder if FRBs might be signals from intelligent life. Could a repeating FRB be a cosmic beacon, like a lighthouse flashing across space? Could a one-time burst be a message that traveled for billions of years, only to arrive when we were ready to listen? Most scientists believe the natural explanations make more sense, but until we know for sure, FRBs keep our imaginations wide open. What makes FRBs even more special is that they can help us learn about the universe in other ways too. As these bursts travel through space, they pass through clouds of gas and dust. This slows them down a tiny bit and spreads out their signal. By studying these changes, scientists can map the invisible matter between galaxies and learn about how the universe is put together. To catch these quick flashes, astronomers use giant radio telescopes like the Canadian Hydrogen Intensity Mapping Experiment, CHIME in Canada, and the Parkes Observatory in Australia. These telescopes scan the sky night and day, hoping to catch an FRB in action. New technology and computer programs help sift through mountains of data to find these brief, bright signals. Each FRB we find is like a puzzle piece. One by one, they bring us closer to understanding what makes them happen. But for now, the picture is still incomplete. We know they are powerful. We know they come from far away. We know some repeat, while others do not, but we do not yet know why. So tonight, as you drift off to sleep, imagine those tiny flashes lighting up the darkness. Picture them racing across billions of light years, carrying secrets from distant corners of the universe. Maybe they are echoes of stars breaking apart, or whispers from magnetic giants, or something stranger still. Each FRB is a reminder that the universe still holds mysteries we have only just begun to hear, and that sometimes the quietest signals are the ones that keep us wondering the most. Oumuamua, visitor from beyond? In late 2017, astronomers around the world turned their eyes to a strange object passing through our solar system. At first glance, it looked like just another asteroid or comet drifting among the planets. But very quickly, it became clear that this was something different. This visitor was not from our solar system at all. It came from far beyond, carrying secrets from a place we may never see. Its name is Oumuamua, a Hawaiian word that means scout or messenger from afar, arriving first. Oumuamua is the first known interstellar object to pass through our solar system. Before it, every comet or asteroid we had ever found came from our own cosmic neighborhood. Some came from the distant Oort cloud, a shell of icy objects that surrounds our solar system like a bubble. Others came from the asteroid belt between Mars and Jupiter, but Oumuamua was special because it came from outside that bubble. It did not orbit the sun like our planets do. Instead, it flew in from deep space and kept going, never to return. Astronomers first spotted Oumuamua in October 2017 using a telescope in Hawaii. They were scanning the sky for near-Earth asteroids that might come too close to our planet. When they plotted Oumuamua's path, they saw that it was moving incredibly fast, too fast to be bound by the sun's gravity. It had already swung around the sun and was on its way back out, speeding toward the edges of the solar system again. The shape and movement of Oumuamua puzzled scientists right away. Unlike most asteroids, which tend to be round or potato-shaped, Oumuamua seemed long and narrow, more like a cigar, or maybe even a pancake. Some studies suggested it could be up to 10 times longer than it was wide. As it spun through space, its brightness changed dramatically, which fit the idea that it was shaped like a strange, tumbling shard. Its path was odd too. As it passed through the inner solar system, Oumuamua sped up slightly, drifting off the course that gravity alone would have given it. comets often do this because as they warm up near the sun, they release gas and dust that pushes them along like a jet. But Oumuamua showed no clear signs of a comet's fuzzy tail or glowing coma. No gas cloud was seen. This left scientists with a puzzle. What was pushing it? These unusual traits led to lots of ideas. Was Oumuamua an asteroid, a chunk of rock broken off from a planet, or a bigger object? Was it a comet that somehow lost all its surface ice long ago, or was it something else entirely? One idea that got a lot of attention was that Oumuamua could be artificial, maybe even a piece of alien technology, like a probe or a light sail sent out to drift among the stars. This idea was made popular by some scientists, like Avi Loeb, who argued that its odd shape, its gentle acceleration, and its lack of a tail could mean it was designed, not made by nature. Most scientists think a natural explanation is more likely. One theory is that Oumuamua is a piece of a larger object that was torn apart by the gravity of its home star. It could be made of hydrogen ice that evaporated too slowly to make a visible tail, or maybe it was covered with a dark coating of organic material that hid any escaping gas. These ideas help explain why Oumuamua did not look like a typical comet or asteroid. Whatever it is, Oumuamua taught us that the space between stars is not empty. It showed that chunks of rock and ice can travel incredible distances, crossing the cold darkness between star systems. It also showed us that we have only just begun to notice these travelers. Oumuamua was already on its way out when we found it. It passed closest to Earth about 40 days before its discovery. By the time we saw it, there was no chance to send a spacecraft to chase it. We could only watch as it drifted away. Since then, astronomers have looked for other interstellar visitors, and in 2019, they found one, Comet Borisov, another traveler from beyond our solar system. Unlike Oumuamua, Borisov looked like a classic comet, with a bright tail of gas and dust. Its presence confirmed that interstellar objects are not just rare accidents, they may be passing through all the time. We just need the right tools to catch them. Scientists are now building new telescopes and designing new ways to watch the sky. They hope that next time we will spot one of these cosmic messengers sooner. Maybe we will even launch a probe to intercept it, collecting data up close to see what secrets it carries from its home among the stars. So tonight, as you drift off to sleep, picture Oumuamua silently gliding through space, a lonely scout from somewhere far beyond our sun. Imagine the stories it could tell of ancient worlds, dying stars, and the vast journey through interstellar darkness. It reminds us that our solar system is not an island, but part of a much bigger ocean, full of wandering visitors who pass by quietly, carrying the secrets of the galaxy with them. The UFO/UAP rebut. For as long as people have looked up at the night sky, they have seen strange things they could not explain. Bright lights that moved too fast, shapes that hovered without sound, objects that seemed to disappear into thin air. For decades, many people called these mysteries UFOs, which stands for Unidentified Flying Objects. The word UFO quickly became tangled up with alien spaceships and wild stories. But in recent years, scientists and governments have tried to give this topic a fresh look and a new name, UAP, which stands for Unidentified Aerial Phenomena. What makes this moment different is that respected institutions are taking these sightings more seriously than ever before. In the United States, the Department of Defense and the Pentagon have started to share some information about what pilots and radar operators have seen in the skies. These are not blurry photos taken from someone's backyard. These are reports from trained military pilots using advanced jets, radar systems, and infrared cameras. One of the big moments that brought UAPs back into the news was a set of videos recorded by US Navy pilots. In 2004, 2014, and 2015, fighter pilots off the coasts of California and the East Coast captured footage of strange objects. In one famous case, the pilots saw what they described as a tic-tac, a smooth, white object about the size of a small plane, but without wings, engines, or exhaust. The object moved in ways that seemed to defy our understanding of flight. It changed direction instantly and accelerated so fast that no known aircraft could keep up. Radar operators also tracked these objects. They saw them appear and disappear in ways that did not match the patterns of birds, weather balloons, or regular planes. In some cases, multiple sensors, radar, infrared cameras, and the pilot's own eyes all saw the same thing at the same time. This makes it harder to dismiss these sightings as simple equipment glitches. In 2020 and 2021, the US government took an unusual step. The Pentagon set up a task force to collect and study these reports. Congress asked for an official report on what the military knows about UAPs. The report did not say that these objects were alien spacecraft, but it did admit something important. Some of these sightings cannot be easily explained. Out of hundreds of cases, most could be linked to things like drones, weather conditions, or optical illusions, but a small number remain unexplained. What makes these cases interesting is not just the eyewitness stories, it is the data, radar tracks, infrared images, and flight patterns that do not follow the normal rules of physics as we know them. Some of these objects seem to fly at high speeds without visible engines. Some appear to hover motionless against strong winds. Others change direction instantly without slowing down. If these reports are accurate, they could point to technology that we do not yet understand. Scientists stress that unexplained does not mean proof of aliens. It means we need to ask better questions and gather more evidence. Many experts believe there could be simple answers that we just have not found yet. Atmospheric effects, new kinds of drones, or unknown natural phenomena might be behind some of these sightings, but without clear data, we cannot say for sure. What is new and hopeful is that scientists want to study these mysteries with an open but careful mind. Organizations like NASA and respected universities have called for more rigorous research. They want to use better sensors, share data across agencies, and study these events without fear of ridicule. For a long time, people who saw something strange were afraid to speak up because they did not want to be laughed at. Now pilots and scientists are starting to talk openly, helping to replace rumor and guesswork with real investigation. This UAP reboot shows us that science works best when it keeps an open mind, but also demands proof. It reminds us that curiosity and skepticism go hand in hand. It is okay to be amazed by something we do not understand, as long as we look for real answers instead of jumping to wild conclusions. By focusing on hard data and physics, we can sort out what is possible, what is probable, and what might be truly new. In the future, better technology could help us see these objects more clearly. New satellites, high-resolution radar, and AI-powered analysis might reveal patterns we missed before. Maybe we will discover a new type of natural phenomenon. Maybe we will find evidence of advanced technology from another country. Or maybe, just maybe, we will find something even more surprising. Whatever the truth is, it will bring us closer to understanding our place in the sky and beyond. So tonight, as you drift off to sleep, Picture those silent shapes moving through the night, leaving trails on radar screens and questions in our minds. Imagine scientists and pilots working together to gather clues, piece by piece, searching for the truth behind the lights that have puzzled people for generations. The sky is full of mysteries, and sometimes all we need to do is keep looking up, ready to learn whatever it has to show us. Are we looking in the right way? When we think about searching for life in the universe, we usually picture radio telescopes sweeping the sky, waiting for a signal to arrive from some distant star. This is how SETI, the search for extraterrestrial intelligence, has worked for decades. We tune in to the same kinds of radio waves we use here on Earth, hoping that somewhere another civilization is sending out messages we can catch. But what if we are not looking in the right way? What if the signals are all around us, but we just do not know how to notice them yet? This question is an important one. It reminds us that our search for other life is shaped by our own experience. On Earth, radio waves have been part of our technology for just over 100 years. In that short time, they have changed the world. We send news and music through the air. We talk to people on the other side of the planet without wires. We even communicate with our spacecraft exploring the edge of the solar system. It makes sense that we expect other intelligent beings to use something similar. But radio waves are only one piece of the puzzle. They are convenient for us because they can travel long distances through space without being absorbed by dust and gas. They can carry lots of information, and we know how to detect them. Still, in the vast timeline of any civilization, radio might only be used for a short while. Imagine a society that grows far beyond what we know today. They might discover better ways to talk across the stars, ways that use forms of energy or physics we have not invented yet. Some scientists think that advanced civilizations could use lasers instead of radio waves. Lasers can send tightly focused beams of light across huge distances. We have already used lasers for things like secure communication and measuring the distance to the moon. A super advanced species could build giant laser systems to send pulses of light that contain huge amounts of information. If we are only listening for radio, we could miss these flashes entirely. Others wonder if truly advanced life could use something even stranger, like manipulating gravity waves or using quantum entanglement to send messages instantly. These ideas come from the edge of what we understand about physics today. Gravity waves were first predicted by Einstein, but it took us 100 years to prove they exist. If an alien civilization mastered them, we might not recognize the signal, even if it was right under our noses. It is also possible that advanced civilizations do not send signals at all. They might communicate in ways that are completely passive to us. For example, they could use technosignatures, which are indirect clues that technology is at work. These could be giant structures that block starlight in a pattern, or a planet covered in lights that change in unnatural ways. Some scientists look for the chemical fingerprints of pollution in the atmospheres of exoplanets. If we found an atmosphere with gases that should not be there naturally, it might mean an industrial civilization is at work. The idea that we might not be listening correctly does not mean our search is wasted. Instead, it pushes us to be creative and keep our minds open. It is a reminder that our technology is just one tiny chapter in the story of what might be possible. Think about how much our own world has changed in just the past century. 100 years ago, there were no cell phones, no satellites, and no internet. 1,000 years ago, there were no telescopes at all. Now, we can see planets around other stars and detect faint signals from billions of light years away. If life is common in the universe, we may have to find it in ways we do not expect. It could mean looking for signs of giant solar panels orbiting distant stars, or listening for pulses of laser light instead of the steady hum of radio. It could mean searching for clues in the way a planet glows at night, or spotting strange patterns in the heat it gives off. One of the most exciting things about asking whether we are looking in the right way is that it invites everyone to wonder. You do not have to be an astronomer to dream up a new idea. Many breakthroughs in science happen when someone asks a question that seems too simple at first. What if we looked here instead? What if we listened differently? This spirit of curiosity keeps our search alive. So tonight, as you close your eyes and drift off to sleep, think about the signals that might be passing through the air around you. Maybe they are just natural noise, or maybe they are messages waiting for us to invent the right tools to hear them. Somewhere out there, another civilization might be asking the same question. Are we looking in the right way? And maybe someday, our ways of listening and their ways of speaking will finally meet in the quiet dark of space. Alien microbes versus little green men. When people hear the words alien life, they often picture little green beings with big eyes and flying saucers. Movies, books, and television have filled our heads with stories about intelligent aliens zooming around the galaxy in shiny spaceships. But if we are honest about what is most likely to be out there, the truth is probably far simpler and much smaller. The next big discovery in our search for life may not be an advanced civilization. It may not even be a creature with eyes or legs. It might be something tiny, like a simple microbe. Here on Earth, life began as single-celled organisms more than 3.5 billion years ago. For a huge part of our planet's history, there were no animals, no trees, and certainly no people. Earth was a world of bacteria and other microscopic life. These tiny cells were busy doing the work of making oxygen, breaking down minerals, and setting the stage for more complex life to come. Without them, life as we know it would not exist. This long history of simple life makes scientists think that microbes are far more likely to be found on other worlds than intelligent aliens with spaceships. The reason is simple. Bacteria and other simple life forms can live almost anywhere. They can survive extreme heat, freezing cold, intense radiation, high pressure, and complete darkness. They do not need a cozy planet with mild weather. They only need the basic ingredients: water, energy, and some key chemicals. We see this on Earth in places that would seem deadly to most other forms of life. In deep ocean trenches, tiny microbes live around hydrothermal vents, where the water is hotter than boiling. In icy glaciers and permafrost, some bacteria go dormant for thousands of years and come back to life when conditions improve. Even in dry deserts, microbes can hide in tiny cracks in rocks, protected from the blazing sun and harsh winds. These tiny survivors are called Extreophiles, and they remind us that life is incredibly good at finding a way to hold on. When we look at other places in our solar system, the signs of life, if they exist, are most likely to be microbial. Mars is a good example. Billions of years ago, Mars had flowing rivers, lakes, and maybe even an ocean. Today, the surface is cold and dry, blasted by radiation from the sun, but deep underground, there could still be pockets of liquid water. If we find life there one day, it will almost certainly be tiny, simple bacteria or ancient microbes that found a safe place to hide below the surface. The same is true for the icy moons like Europa and Enceladus. These worlds may have salty oceans under thick layers of ice. Warmth from their cores could create conditions similar to Earth's deep-sea vents. Scientists believe that if life exists in these hidden oceans, it would probably be tiny cells drifting in the dark, feeding on minerals and chemical energy. There would be no forests or fish, just the quiet, simple life of microbes. Some people might feel disappointed by this idea. Where is the excitement in discovering bacteria when we dream of meeting beings who can build cities or send signals across the stars? But finding alien microbes would be one of the greatest discoveries in human history. It would show that life is not unique to Earth. It would prove that the conditions needed for life can happen more than once, and if life happened twice, it could happen countless times throughout the universe. Finding simple life would also teach us how life begins and survives. Scientists could study how alien microbes are different from Earth's. Do they use DNA like we do, or something completely new? Do they have unique ways to get energy? Each tiny cell would be a clue to how life can take root on worlds very different from our own. Of course, the search for intelligent life will always continue too. Projects like SETI keep listening for signals. Telescopes keep looking for signs of advanced civilizations, like artificial lights or pollution in the atmosphere of distant planets. But intelligent life needs many things to line up just right. It has to survive long enough to send signals into space. It has to develop technology. It has to want to be found. The odds of all that happening may be much smaller than the odds of tiny cells growing in a warm ocean beneath the ice. So tonight, as you drift off to sleep, picture a tiny alien cell floating in a droplet of water under miles of frozen shell. Imagine it dividing slowly in the dark, a survivor in a place we once thought lifeless. It is not a little green man with a spaceship, but it is living proof that we are not alone. Sometimes the smallest discoveries have the biggest stories to tell, reminding us that life, no matter how tiny, is one of the greatest wonders the universe can offer. How future missions search. As long as people have looked up at the stars, we have wondered what is out there. Today, we have tools that our ancestors could never have dreamed of. Giant telescopes, robotic rovers, and spacecraft that travel millions of miles from home. And yet the biggest question remains, are we alone? To answer this, scientists are designing new missions that search for life in ways that are smarter, sharper, and more precise than ever before. From peering deep into alien atmospheres to digging into the dusty soil of Mars, these future missions bring us closer to discovering the truth. One of the most powerful tools we have now is the James Webb Space Telescope, or JWST. Launched in December 2021, it is sometimes called the successor to the famous Hubble telescope. While Hubble showed us dazzling images of distant galaxies and stars, the James Webb was designed to look even deeper and catch faint details that Hubble could not see. One of its most exciting tasks is to sniff the atmospheres of exoplanets, planets that orbit stars far beyond our own sun. How does a telescope sniff an atmosphere? It works like this. When a planet passes in front of its star, some of the starlight filters through the planet's atmosphere before reaching us. That thin layer of gas can leave tiny fingerprints on the light patterns that tell us what chemicals are there. By studying these fingerprints, scientists can figure out if a planet has water vapor, oxygen, methane, or carbon dioxide. These are not just random gases. On Earth, they are closely linked to life. Finding a mix of gases like oxygen and methane on another world would be an exciting hint that something, maybe plants, maybe microbes, is producing them. Of course, nature can make some of these chemicals without life too, so scientists have to be careful. But this kind of careful sniffing is one of our best ways to search for what are called biosignatures, signs that life might be at work. While the James Webb peers deep into space, other missions focus much closer to home. Mars has always been one of our best hopes for finding signs of life. Today, NASA's Perseverance rover is driving across an ancient lake bed on Mars, looking for tiny clues hidden in rocks and soil. Perseverance has a partner called the Ingenuity helicopter, which helps scout the best paths to explore. Perseverance drills into Martian rocks, collects samples, and even seals them in tubes that a future mission will bring back to Earth. These Mars samples could tell us if tiny microbes ever lived in Mars's ancient rivers and lakes. And Mars is not the only place getting attention. Moons like Europa and Enceladus hold oceans of liquid water under their icy shells. Future missions plan to fly through the plumes that burst out of Enceladus or drill into Europa's surface to taste what is hidden below. A mission called Europa Clipper will launch in the coming years to orbit Jupiter and make many close passes over Europa, using radar and other tools to look for places where life could survive. New telescopes are also on the way. The extremely large telescope in Chile will be one of the biggest ground-based telescopes ever built. With a mirror almost 130 feet wide, it will be able to look at exoplanets in amazing detail. Scientists hope it will see clouds, storms, and even hints of continents on distant worlds. Other space telescopes like the Nancy Grace Roman Space Telescope and future projects like LUVOIR and HABEX could be even more powerful. Some might use a clever shield called a star shade to block out a star's bright light so they can see the faint glow of its planets. These tools are like adding new senses to our eyes and ears. They help us see, smell, and even feel what is happening on worlds we cannot touch yet. But technology alone is not enough. Every mission needs people, scientists, engineers, and dreamers who plan the questions to ask and build the machines to go looking for answers. In the years ahead, we may not find little green people waving from a spaceship, but we could find bacteria on Mars, hidden in the soil, or microbes swimming in Europa's salty ocean. We could detect strange chemical patterns in a planet's atmosphere light years away, patterns that whisper that something alive is breathing there. Each discovery, big or small, will remind us that we are part of something larger than just our blue planet. So tonight, as you drift off to sleep, think of the James Webb peering through the darkness, of rovers climbing over red rocks on Mars, of future probes drilling through ice to taste ancient water. Picture the next questions we will ask and the answers waiting to be found. Somewhere out there, life might be growing in places we can hardly imagine. And when we find it, we will know that our search, our long journey to understand who we share this universe with, has only just begun. Technosignatures, alien tech traces. When we talk about searching for life beyond Earth, we often think of tiny microbes hiding in the soil of Mars or drifting deep in the oceans beneath icy moons. But there is another way to look for life, not just for signs of something living, but for signs that something is building, changing, and shaping its world in ways that nature alone cannot. These clues are called technosignatures. A technosignature is any signal or footprint that shows advanced technology might be at work. It is like finding an artificial light in the distance, or hearing a hum that nature could never make on its own. The idea behind technosignatures is simple. If a civilization becomes advanced enough, it will use energy and resources in ways that stand out. Just like our cities glow at night when seen from space, other worlds could have signs that someone lives there and is doing things that planets without life simply do not do. One of the clearest examples of a technosignature is light pollution. On Earth, satellites can easily see the glow of our cities at night. Imagine looking at our planet from far away. During the day, you might see continents and clouds, but at night, the dark side of Earth twinkles with millions of lights. This glow is not natural. It is the product of billions of bulbs, signs, and street lamps that humans built. If we can see our own lights, maybe one day we could see the lights of another civilization. Some scientists have even suggested that telescopes of the future could look for patterns of light on the dark side of distant planets, patterns that do not match natural fires or volcanoes. Another idea is that an advanced civilization might build huge structures in space, structures so big that they would change the way their star looks to us. One of the most famous examples is the Dyson sphere. This idea was first suggested by the scientist Freeman Dyson in the 1960s. He wondered if a civilization keeps growing, it will need more and more energy. What if, instead of burning fuel, they found a way to capture all the energy from their sun? They could build a swarm of giant satellites or mirrors that surround the star, soaking up its power. From far away, that star would look strange. It would be dimmer than it should be in some parts of the light spectrum, and might give off extra heat in the infrared. Scientists today search for stars that look like this, too faint in the visible light, but too bright in infrared, because they might be surrounded by a Dyson sphere. We can also look for strange patterns in radio waves or laser signals. If an advanced species uses powerful beams of energy to send messages, push ships, or transfer power, those beams might reach our telescopes. Unlike the constant hum of natural sources, a technosignature signal might look like a sharp spike repeating at regular intervals or coming from a place where we would not expect to find it. Pollution is another possible clue. On Earth, certain chemicals in our atmosphere, like chlorofluorocarbons (CFCs), do not appear naturally. They were created by humans and used in things like old refrigerators and air conditioners. If we ever found these chemicals in the air of a distant planet, it could be a hint that technology is changing that world. Even a trace of artificial chemicals could stand out as a whisper that someone is there. Looking for technosignatures is a big challenge. Space is huge, and the signs might be faint. Advanced civilizations might also build in ways that are very different from what we expect. They could be so far ahead that their technology leaves no trace we can understand. Or maybe they hide on purpose, not wanting to be found, but the search pushes us to think creatively and expand what we look for. Instead of only hunting for life that looks like us, we think about what we would build if we had endless time and resources, and then ask what hints that might leave behind. New telescopes and powerful computers are making this search more possible than ever. Scientists sift through data from thousands of stars, looking for unusual dips in brightness, odd patterns of heat, or signals that repeat in a way nature would not do alone. Every time we build a better tool, we open a new window into the possibility that we might not be the only builders in the universe. Technosignatures remind us that the story of life does not have to end with bacteria or small creatures in hidden oceans. Somewhere there might be beings that have changed their worlds completely, and in doing so, left a mark that travels light years to reach us. So tonight, as you drift off to sleep, imagine distant planets with shining cities, giant solar structures orbiting their suns, or faint glimmers of artificial light crossing the dark. These possibilities are out there, waiting for our eyes, our minds, and our curiosity to find them. One day, that glimmer could be the clue that finally tells us we are not alone. Cosmic loneliness versus cosmic family. Since the first people looked up at the night sky, we have wondered the same thing. Are we alone? This question runs through every part of our search for life beyond Earth. We build telescopes to peer at distant planets. We send rovers to crawl across the red soil of Mars. We listen for whispers from the stars, hoping for a signal that someone else is out there. But behind all this technology and science is a deeper, more human feeling, the hope that we are part of a bigger story. Right now, as far as we know, Earth is the only place with life. Our forests, oceans, animals, and people are part of a single precious oasis floating in a vast, dark sea. This knowledge makes us feel both special and small. Some people call it cosmic loneliness, the idea that in all the billions of stars and galaxies, we might be the only living things. But what if we find out that is not true? What if, tomorrow, a tiny microbe is discovered under the Martian soil, or drifting in the oceans under Europa's ice? What would that change for us? First, even finding the simplest alien life, a single cell, not a civilization, would be one of the greatest discoveries in human history. It would prove that life is not a miracle that happened just once. It would show that when the right ingredients come together, life can spark more than once in the universe. Suddenly, the odds would feel different. If life happened here and there, maybe it happened in many other places too, worlds we have not yet seen or even imagined. This shift would change how we see our own planet. Earth would still be special, but it would no longer feel so alone. Instead, it would feel like one part of a giant cosmic family. Each world with life, no matter how simple, would be like a distant cousin. The bacteria under Martian rocks, or the tiny cells in Enceladus's ocean, would remind us that life wants to grow and survive, even in the harshest places. It would make the universe feel less empty and more alive. This discovery would also make us think more deeply about how we treat our own world. If life is precious enough to search for across millions of miles, maybe it is precious enough to protect here too. Seeing how fragile life can be might remind us to take better care of our forests, rivers, and oceans, and each other. It might help us understand that our place in the cosmos is not just to explore, but to care for what we find, both out there and right here at home. Finding even a single alien microbe would raise questions that scientists would study for generations. How did it survive? How is it different from life on Earth? Does it use the same building blocks like DNA and proteins, or did it find another way? These questions would help us learn more about what life really is and how many forms it could take. It might even help us understand our own beginnings better, giving us clues about how life first sparked on Earth billions of years ago. But there is another side to this too. Some people say they would feel comforted by knowing we are not alone. Others wonder if it would make us feel even smaller. If life can exist in many places, what does that mean for humans? Are we just one more species in a vast cosmic zoo? Would the knowledge make our lives feel less meaningful, or would it inspire us to reach out and learn more? Many believe it would bring people closer together. Right now, our world often feels divided by borders, languages, and disagreements. But seeing ourselves as part of a wider family, with neighbors across the stars, even if they are just tiny microbes, might help us see that what we share is bigger than what separates us. The pale blue dot would feel less lonely. We would not just be Earthlings anymore. We would be members of a living universe. And what if one day we find not just microbes, but something more, an intelligent signal, a techno-signature, or even another civilization that would push our sense of cosmic family to a whole new level? We would have proof that thinking beings can exist elsewhere, asking the same questions we do. But it all starts with the first tiny clue, one small cell drifting quietly in an alien sea, showing us that we were never completely alone. So tonight, as you drift off to sleep, think about that idea. Somewhere in the endless darkness, life might be growing in tiny pockets, waiting to be found. And when we do find it, our sense of place will change forever. Our loneliness will fade. replaced by the wonder of knowing that in the vast, silent cosmos, we are part of a much bigger, living family, and that family story is just beginning to be told. Why the proof is hard. Every time we look up at the stars, it feels like the universe should be full of life. We see billions of galaxies, each with billions of stars, many with planets that might have oceans, air, and warmth. With so many possible homes for life, it seems reasonable to think that we should have proof by now. A signal from intelligent beings, a fossil from Mars, or even microbes from an icy moon. But so far, we have found no clear, undeniable evidence that life exists anywhere else. Why is it so hard to find proof? The answer lies in the vast distances, the limits of our technology, and the simple fact that time itself does not always work in our favor. One of the biggest reasons the search is so challenging is distance. Space is not just big, it is unimaginably vast. Our closest star neighbor, Proxima Centauri, is about 4 light years away. That means light, which travels incredibly fast, takes 4 years to get from there to here. And that is just the closest star. Most of the stars we look at with our telescopes are dozens, hundreds, or even thousands of light years away. So when we see them, we are looking into the past. We do not see them as they are now, but as they were when the light first left them. This distance makes sending and receiving messages incredibly difficult. Imagine that an intelligent civilization lives on a planet orbiting a star 1,000 light years away. If they sent us a message today, we would not get it for 1,000 years. If we replied right away, they would not hear our answer for another 1,000 years. By the time any real conversation could happen, entire human civilizations could rise and fall. This is one of the biggest challenges with direct contact. The universe is not just big in space, it is big in time too. This brings us to the second problem, the time factor. Life on Earth has existed for about 4 billion years, but humans, people who could build radios, rockets, and telescopes, have only been around for a tiny slice of that time. For most of Earth's history, there were no cities, no machines, and no one who could send a signal to the stars. We have only been sending out radio waves for about 100 years. That means our bubble of signals has only traveled about 100 light years from Earth. Compared to the size of the galaxy, that is nothing at all. Now, think about another civilization out there. They might have developed technology millions of years before us, or millions of years after. If their window of sending signals does not line up with ours, we could miss them completely. They might have thrived, sent out their signals, and then disappeared long before humans even learned to walk on 2 legs. Or they might still be microbes in a young ocean, waiting for their chance to evolve. The odds that 2 civilizations would exist at the same time, be advanced enough to communicate, and actually be close enough to detect each other are very small. Then there is the question of what kind of signals to look for. We listen for radio waves because that is what we know how to send. But what if another civilization uses something different? Lasers, neutrinos, or methods we do not even understand yet? If we are listening to the wrong frequency, we could be surrounded by signals but never hear them. This is why some scientists say our search is like trying to find a single voice whispering in a storm. Technology is another challenge. Our tools are getting better every year, but they are still limited. We can barely see the details of planets orbiting distant stars. We can only sniff the edges of their atmospheres to guess what gases might be there. Sending spacecraft to another star would take tens of thousands of years with today's technology. So instead, we look for clues from far away, hoping that a signal, a chemical marker, or a strange heat pattern might point the way. All of this can feel discouraging, but it also reminds us that patience is part of the search. Every new telescope, rover, or probe brings us a little closer to finding answers. We learn more about how planets form, how atmospheres change, and how life could take hold in places we never expected. The proof may be hidden in a rock beneath Mars's surface, in a droplet of water under Europa's ice, or drifting in a signal we have not yet learned how to hear. So tonight, as you drift off to sleep, remember that the silence does not mean we are alone. It means the universe is vast, and finding another spark of life is one of the hardest, most important questions we can ever ask. Our search is a reminder of our place, small, curious, and brave enough to keep listening and looking, even when the answers hide behind thousands of light years and millions of years of time. The proof is out there, and one day it may come to us when we least expect it, changing how we see ourselves forever. Why we keep searching. For as long as people have looked up at the stars, we have asked the same question: are we alone? This question has echoed through every culture, every generation, and every curious mind that ever gazed at the night sky. From ancient stargazers who told stories about constellations, to modern scientists who send probes across millions of miles, that question remains at the heart of what makes us human. It is part of our nature to wonder, to dream, and to search for answers, even when they seem far out of reach. Why do we keep searching for life out there? The answer starts with our spirit of curiosity. Humans are explorers by nature. Long before we had rockets or telescopes, we crossed oceans and climbed mountains just to see what was on the other side. We asked questions about the world and built tools to help us find the answers. That same curiosity drives us today as we build powerful telescopes, send rovers to distant planets, and listen for faint whispers from the stars. The search for life beyond Earth is more than just a scientific project. It is a journey that brings people together. It takes engineers, astronomers, biologists, computer scientists, and dreamers working side by side. They come from different countries, speak different languages, and often disagree about how to do things, but they share the same goal: to find out if we have company in this vast universe. This shared curiosity is a reminder that some questions are bigger than any one person or nation. The truth is, we do not know if we will find what we are looking for. The universe is huge. It takes light years to cross even the small corners of our galaxy. Signals fade, planets hide behind their stars. Life, if it is out there, might be tiny and hard to see, but that does not stop us. We keep searching because even the smallest clue would change everything. Finding a fossil on Mars, a strange microbe in an ocean under an icy moon, or a signal that says we are here would be enough to rewrite what we know about life. Imagine what it would mean to find even the simplest proof. It would show that Earth is not special because it has life, but part of a larger family of living worlds. It would tell us that life is not a rare accident, but a natural part of the universe. That idea can give people hope. It means we are not as alone as we once thought. It means that across the darkness, there may be others wondering the same thing, asking the same questions. This search also helps us see ourselves in a new way. Looking for life out there makes us think about how we care for life here at home. We realize how fragile our world is, floating in the blackness of space. It reminds us that Earth is not just our home, but the only place we know for sure has life. That makes it worth protecting, not just for us, but for every creature that shares it with us. Sometimes people ask if it is worth the effort. Why spend time and money on telescopes, rovers, and radio signals when there are problems right here on Earth. But our curiosity and our everyday lives are not separate things. The same science that searches for life on other planets helps us understand our own. Technology built to sniff out chemicals on Mars can help detect pollution in our air and water. Ideas for surviving on icy moons teach us how to grow food in harsh conditions. Every mission, every question, and every new tool we build for space often finds its way back to Earth, making life here better. Even if we never find another living thing, the search itself is a gift. It teaches us patience, creativity, and the power of asking what if. It reminds us that we are small, but capable of big dreams. It shows us that there is still so much we do not know, and that is a beautiful thing. So tonight, as you drift off to sleep, think about that spirit of wonder that lives in you too. Picture scientists staring through telescopes, engineers building spacecraft, and children looking at the stars for the very first time. All of us are connected by this quiet, powerful question. We search not because we have to, but because deep down, we believe that even one glimpse of life out there, even the tiniest microbe or faintest signal, would remind us that the universe is bigger, brighter, and more alive than we ever dreamed. And that hope, that shared curiosity, is reason enough to keep looking up and asking the question that has always made us human. What science needs to know next? After centuries of asking if we are alone in the universe, we stand at an exciting point in our search. We have sent rovers to Mars, flown by distant moons, scanned thousands of exoplanets, and tuned our giant radio telescopes to listen for signals from the stars. Yet the biggest question remains: where is the proof? What would it take to find that final clue that shows life exists beyond Earth? The answer is clear. We have to keep looking, but we must look in smarter, deeper, and more creative ways. To do that, science needs to know what to focus on next. One of the biggest steps ahead is bringing home pieces of other worlds. Mars has been our main target for decades because it is nearby, once had flowing rivers and lakes, and still holds ice underground. Rovers like Perseverance are not just snapping photos or drilling tiny holes in rocks. They are carefully collecting samples, bits of soil, pieces of ancient lake beds, and rock cores, and sealing them in tubes that will stay untouched until they come back to Earth. This is called a sample return mission. Why is a sample return so important? It is because our best labs are still here on Earth. Even the smartest rover has limits. It can only carry so many tools, and it must survive Mars's harsh dust storms, radiation, and extreme cold. By bringing pieces of Mars back to Earth, scientists can use advanced microscopes and chemical tests to look for fossilized microbes, organic molecules, or tiny chemical fingerprints that might prove life once existed there. This work must be slow and careful. One false result could send us chasing ghosts. But with real samples, we can test and retest until we are sure. Mars is not the only place we want to study up close. Icy moons like Europa and Enceladus are now high on our list too. Spacecraft like Europa Clipper will orbit Jupiter and scan Europa's cracked surface, searching for the best spots to study. This moon is special because it likely has a huge ocean under its ice, an ocean with more water than all of Earth's seas combined. Some of this water may even leak out through cracks and geysers, forming giant plumes that shoot into space. Imagine flying a spacecraft through those plumes and catching droplets from Europa's hidden ocean. If these droplets hold organic molecules, or even more exciting, tiny cells, it could be the first sign of life in an alien ocean. We also need better ways to listen for distant signals. For decades, SETI has listened for radio waves, hoping to catch a message from intelligent beings. But new ideas say we should not stop at radio. Maybe advanced civilizations use lasers, sending narrow beams of light instead of wide radio broadcasts. Or maybe they leave behind techno-signatures, strange patterns of light, heat, or chemicals in their planet's atmosphere that nature could never make alone. To find these faint clues, we need bigger and more sensitive telescopes. Telescopes like the James Webb Space Telescope are already looking at exoplanets, sniffing their atmospheres for gases linked to life. But scientists dream of the next generation, telescopes with star shades that block a star's glare, letting us see the dim glow of a small planet beside it. Instruments like these could detect city lights on a distant world, or the warm heat of giant structures built to capture energy from their star. Science must also keep pushing new ideas that may sound strange at first. Some researchers are studying quantum communication, wondering if distant civilizations could use physics we do not yet fully understand. Others are looking for repeating signals called fast radio bursts that might, in some rare cases, turn out to be artificial. Even the study of our own solar system could reveal secrets. Some scientists think that objects like Oumuamua, the interstellar visitor that passed through in 2017, might be natural, but others wonder if we should keep an open mind, that such objects could someday be something more. All of this work takes teamwork, time, and curiosity. Scientists must protect samples from contamination so they do not mistake Earth germs for alien life. Engineers must design spacecraft that can drill through miles of ice without breaking. Computer experts must sort through mountains of data, looking for tiny patterns in the noise. And everyone must remember that the search is not about proving our hopes, but about finding the truth, no matter what it is. So tonight, as you close your eyes, think about the questions we still need to answer. Picture the tubes of Martian soil waiting to come home, the spacecraft diving through Europa's icy plumes, and the giant dishes turning toward the stars, hoping to catch a whisper across the void. Each tiny clue brings us closer to an answer that could change how we see ourselves forever. Science still has so much to learn, and that is what makes this journey worth every step. So are we truly alone? After all the science, the missions, the telescopes, the questions, and the dreams, we always come back to the same quiet wonder: are we truly alone? This question sits in the back of our minds when we look up at the stars on a clear night. It floats behind every news headline about a new discovery on Mars, a strange signal from space, or a telescope that glimpses a distant exoplanet for the first time. It is a question that is simple and enormous all at once. If you stand outside on a dark night and look up, the sky might seem still and silent, but beyond what your eyes can see, the universe is alive with motion and possibility. Stars are being born and dying, planets are circling their suns, comets drift for millions of years through icy emptiness. Radio waves and beams of light cross vast distances, carrying messages of what once was. In all of this, it seems impossible to believe that we are alone. And yet so far, every search for proof has come back with the same answer: not yet. But not yet is not the same as never. Every rover digging into Martian soil, every spacecraft skimming icy plumes, every telescope sniffing the atmosphere of a distant world, they remind us that tomorrow's proof could arrive at any moment. One new signal, one tiny fossil, one single cell swimming under an alien ocean. The discovery might not be dramatic at first. It might be something so small you could hold it on the tip of your finger, but its meaning would be bigger than anything else we have ever found. The truth is, The universe does not rush to show its secrets. It moves on scales of time and space that are hard for our human minds to grasp. Life on Earth took billions of years to grow from simple microbes to plants, animals, and people who could ask these questions. It is possible that life elsewhere is still in its early steps, tiny cells forming under miles of ice, or drifting through clouds on a distant planet. Or maybe it bloomed long ago, sent out signals we missed, and faded before we learned how to listen. Sometimes people feel sad when they think about the silence. They wonder if it means we really are alone, a tiny island of life floating in a dark ocean. But maybe the silence is not a reason to feel lonely. Maybe it is a reason to feel hope. It means that our story is still being written. It means there are more questions to ask, more places to search, and more wonders waiting for curious minds to find them. When we ask, are we truly alone, we are also asking what kind of explorers we want to be. Do we keep listening, even when there is no answer? Do we keep sending our robots into the unknown, drilling through ice and crossing deserts of red dust? Do we keep building bigger telescopes and better tools to stretch our senses farther than ever before? Every generation that asks these questions adds its own chapter to the search. And when we look for life out there, we learn more about life here too. We see how rare and precious our blue planet is, covered in forests, oceans, and living things that share this journey with us. We remember that every tree, every drop of water, every creature is part of the miracle we hope to find somewhere else. The search reminds us to protect what we have while we wonder about what might be. So tonight, as you settle in for sleep, think about the countless stars shining far beyond your window. Somewhere in all that darkness, something may be waiting, a single cell clinging to a rock on a cold moon, a signal whispering through the static of space, or a distant being asking the same question. Are we alone? And maybe, just maybe, our paths will cross. Maybe tomorrow will bring that first clue. Maybe not, but the wonder is always there. The universe is not finished telling its story. Each night, each mission, each discovery is like turning a new page. We may not know how or when we will find the answer, but that does not make the question any less beautiful. So keep wondering, keep looking up, keep hoping that one day the silence will break and we will know that in this vast, endless universe, we were never truly alone. And until then, we dream together under the stars. After a long, gentle journey through all the mysteries of our universe, the strange signals, the hidden oceans under ice, the ancient rocks on Mars, and the dreams of other beings looking back at us, it is time to drift into a peaceful sleep. But before you close your eyes, let's hold this soft sense of wonder just a little longer. For tonight, you have explored questions that have fascinated humankind for centuries. You have wandered through fields of stars, crossed vast oceans of space, and stood beside rovers on distant planets. You have imagined microbes clinging to life under frozen shells and giant telescopes, catching whispers from the stars. You have felt the bigness of it all, how tiny we are in this endless expanse, and yet how special it is that we can ask these questions at all. It is easy to feel small when you think about billions of galaxies, each with countless stars and planets. But being small does not mean we are unimportant. It means we are part of something bigger, something that is alive with possibilities we are just beginning to understand. Each night sky is a reminder that the universe is not finished speaking to us. It is still telling its story, and we get to listen, wonder, and add our own chapter. The best part is that this story belongs to all of us. No matter where you live or what language you speak, You share this big spinning world with billions of other dreamers. Somewhere, maybe not so far away, someone else might be looking up at the same stars right now, asking the same questions. Are we alone? Is someone out there thinking about us too? What will we find when we are brave enough to look? These questions remind us that curiosity is a gift. It is a gentle light that keeps us moving forward, even when the answers hide in the dark. It is the spark that builds telescopes, launches rockets, and teaches us how to listen for signals older than any human city. It is the quiet hope that someday, across all these light years, we will find out that we are part of a much bigger family. So tonight, may you drift off with that hope close to your heart. May you dream of distant worlds where oceans hide beneath smooth sheets of ice, where strange lights flicker in alien skies, where life in its tiniest forms might be waiting for us to say hello. May you picture faraway beings looking up from their own lands, wondering if they too are alone, or if someone out there is wondering about them. And when you wake tomorrow, may that same wonder stay with you. Let it remind you that our search for life is not only about what is out there, but what is inside us too. The wish to connect, to learn, and to keep going, even when the road is long. One day, we may find that proof we dream of, a fossil on Mars, a droplet from Europa's ocean, or a signal that crackles through the silence to say, you are not alone. But until that day comes, the search itself is enough to keep our hearts and minds wide open. So, as you lay your head down and feel sleep tug at your thoughts, remember this: may we never stop wondering if someone is out there wondering about us. May we never stop looking up, listening, and asking the questions that make us who we are. Thank you for drifting through the stars with me tonight. If you enjoyed this gentle journey, I invite you to stay curious with us. Please subscribe so you can come back whenever you need a moment to wonder. Tap the like button if this story brought you peace, and leave a comment to tell us where in the world you are listening from tonight. It is always comforting to know we are all connected under the same sky. Now, take a slow breath, close your eyes, and let your mind wander to distant worlds. Somewhere out there, the next clue is waiting. Until we find it, may you sleep soundly and dream deeply under the watchful glow of countless stars. Good night, dear dreamer. You are part of this story, and this story is far from over.